Hello.
Hello, can you hear me?
Yes, I can. Hi.
Awesome. Hi, how are you doing?
I'm doing fine. How are you?
Good, good.
Yeah.
Um, okay, I guess let's just dive right into it. I'll put a question. You can select the language of your choice.
Okay. Yeah, I'm going to do it in Python 3. Yeah.
Okay, perfect. Um, okay, let's say this is your question.
Hmm. Okay. Given two strings, S1 and S2, write a function to return true if S2 contains a permutation of S1. One of the first string's permutation is a substring of the second string. Okay.
So something like A, B versus this other S2.
Mm-hmm.
Um, you will return a true here,
Mm-hmm.
and if this gets separated by something, then you'll return a false.
Got it.
Right?
Got it. Yeah. Okay. Yeah. So it's actually like two problems in one. The crux of the problem is finding all permutations of the string S1, and when you yield one permutation at a time, find out if the permutation is present in string S2, and if it present, then return true. So
Mhm.
that's one approach to do it. Uh, are there any other approaches, like perhaps using dynamic programming? Maybe, but I'm not sure about that. But let's. I can try the first approach of like finding all permutations. Uh, for,
Yeah, sure.
yeah,
Let's do that.
yeah. Okay. So, um, so finding all permutations. The permutations can be found using um, um, it's either okay. So permutations are like take each string and then take characters of each string and rearrange it in a different order. Okay. There is actually graph algorithms to do the permutations like depth first search. Okay. It's either depth first or it's the breadth first. I'm trying to collect one of them, and then we can go doing that. Let me go. Let me write an outline and then define it. Okay, find given two strings S1 S2. Write a function to return true if S2 contains a permutation of string S1. Okay, uh, find permutation S1 comma S2. Okay, for mm, uh, so permutations of a string. So how do I get the permutations of a string? Hmm, I'll think of some way. Usually, like there are higher order functions in Python available, like iter2s, and the iter2s can provide permutations. And uh,
Yeah, let's not use this.
okay, let's not use it. Yeah, I know. Yeah, I get it. Like that's not the point of this. Okay, so um, so permutations. I'm trying to I'm trying to see the depth first search or the breadth first search will be the most suitable one for the permutation. So let's start with AB. So if after selecting A, I have to um, mm, 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 find out all combinations of the rest. That's B, and then I have to select B and find all permutations of the rest of the string A. So um, the way to do that is, okay, let me see. Mm, for I in range of length of S, okay, the character is S of I, and then remaining is is S of I to everything before I, and everything after I. Okay, and then so we have to find out the permutations of that, of remaining. So the way to do that is I derive it. Okay. Um. Okay. I take. So I'll try to do it recursively, and if I do it recursively, it's actually a graph with say A is connected to B, and the way to do it is take A and go to find all the permutations of everything. Um, hmm, okay, I think breadth first search is the option to kind of like find out. Okay, so it's not really depth first search. Um, so we have to take one and all the um, all the different permutations except for the character. Take one and all the different permutations except for the character. So when a breadth first search is involved, we have to have a queue and then pop information from a queue and then put them in order. So yeah, okay. So okay. So what do I place it in the queue? So the string itself is a permutation of that character. So let's start with the queue with the value of the string and string. We'll see if the queue exists, then start with the index. Okay. I'm still devising a strategy for finding the permutations. I have done it once, but I'm kind of like lost in terms of how to write a permutation right now. So I'm trying to find out a strategy and then I'll be able to write it. It's breadth first search, that's I determined. And then the way to write breadth first search is to kind of like have a queue and an index and then permute using this index. So
Okay. Since you're having kind of trouble in permutation, how would you do a permute of 1 2 3? A string like something like 1 2 3. How would you permute 1 2 3?
Okay, so I'll take I'll take 1 and permute 2 and 3, and I'll take 2 and permute 1 and 3. I'll take 3 and permute uh, 1 and 2. And for permuting, huh?
Go ahead.
And permuting 2 and 3. So for 2 and 3,
No,
I'll take.
I get the point. So what strings will it generate?
So the what strings will it generate? Okay.
Yeah.
1, 2, 3, 2, 1, 3, 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Yeah.
Okay. So, like, what did you do over here the first time, or what were you doing in Permute, kind of?
Yeah. So in the permute, I was taking one character and I was fixing on for the two characters. I was simply swapping actually, and what I was essentially doing is I was fixing on one character in the string and then uh, returning the other character, and fixing on the next character and returning the other character.
So basically, last two characters you're just swapping.
Yeah.
Okay. And then you somehow have to get back to 1, 2, 3, or do you continue from the last two characters?
I will have to get back to 1, 2, 3, and yeah, I will have to get back to 1, 2, 3. That
So from here, you again got back to 1, 2, 3, and then what did you do to get to 2, 1, 3?
I fixated on 2 and then considered the two characters 1 and 3.
Okay. So you kind of swapped 2 and 1. So 2 became first, plus you did permute of 1, 3.
Yeah. Yeah. Okay.
Does that make sense?
Yeah. Um, okay.
So, like, do you see where I'm going, kind of?
I see that. Okay. I see in terms of like um, the most important hint of like when there are two characters, I just swapped them and then I fixed on each index, which means that I will have to go one character index at a time and permute the rest of the characters.
Uh-huh.
Uh, and when I'm permuting the rest of the characters, if it is actually uh, two characters, I am swapping. If not, I'm permuting again the rest of the characters. So um, it will okay. I mean, for three characters it will work, but I do not know what will happen for the four characters. But let's start. I will start with the three characters in the code, and then I think I can modify it for the n characters.
Yeah, okay. What will happen if there was only one character?
If there was only one character, it will just return that
Just
length of
return,
the
right?
character.
So what does your ending condition kind of become?
Okay. So my return values, if the length of the character, if the length of the string is 1, just return it. If the length of the string is 2, then uh, swap it. Um, um, otherwise, you kind of like iterate through the indices of the character, pick one character, and then permute to the rest of the characters.
Okay, sure, let's go with that.
Okay. Yeah. Thank you. So. Um, 1.
Also, sorry, I think I missed this. How will you get from 132 to 123 back when you have to go to permute 13?
Um, um, mm, mm. So, how will I get back to 132 to 123 back? So I was imagining that there is a higher, the top level for loop is the one that is actually uh, keeping one character, and then when, okay, so the permute function should have, uh, the permute function should kind of like both for two character permute string, it should return both 3 2 and 2 3, which
Okay,
means that
that gives us 213 and 231. But how
yes.
do we get back to 123? Or like 123 and 132 we get with the two character permute. But how do we get back to 123 after that?
um mm,
Did you get what I was saying?
I think I slightly understand. um
So with one, when we do a permute of 2, 3, with one we got 1 plus 2, 3 and 1 plus 3, 2,
yeah.
right? Now, if there are more than, like this is only for 3 characters. If there are more than 3 characters, then what do we do, right? How do we get back to 1, 2, 3?
Mm-mm. So, uh, do we? I mean, we. Okay. So I think we need to place the character, place the string in a stack, and then kind of like go forward with analyze all the values in that stack, and then push it. That is that I like.
Okay. And like, how will the stack get back to 1, 2, 3
Bec-
again?
So it's we pop the value from the stack and then analyze all the values in the stack, and then we permute the values, and permuting the values will give 1 2 3 and 3 1 3 2,
Mhm.
and then we the permuted. I'm lost. Um, I think I still not, I mean, I am not getting how we are getting there, but once I get that question, I'll do it.
Okay,
Uh,
let's
yeah, yeah.
let's keep going with whatever we're going.
Yes, yes. I think once I understand the question, I think I'll be able to get it. It hasn't struck me yet.
Okay.
Uh, so length of the one is, uh, if the permutation is 1, return yes. If length is 2, um, okay. So that's for two characters for
Mhm.
index and range of length of yes. First character is equal to s of index, and remaining equal to s of let's assume that I pick up one here, and the remaining is actually um, mm, mm, everything before one and everything after one. Okay, and word. And we have to do a permutations of the remaining, and C plus the permutations of remaining, and that's the word, and this will start and B. Let me, yeah, I mean, this is not complete, but I hope this will help me find the problem. So, so I am having a array of results, and for each index in the length of yes, I will go take a character. And here in 1, 2, 3, I'm taking 1, and then remaining is say 2, 3, and permutations of 2, 3 will be, so I'll have 1 with permutations of 2, 3, and permutations of 2, 3 if length is equal to 1, no. So it's
So the permutations question, permutations function returns a list, right?
yeah.
So C plus permutations of remaining will give you will add everything to like C to every element of the list.
I am wrong here. It should not be a single permutation function. So this I will have to write another thing. Permute, which should be I want to so if it is actually I have a length, okay, otherwise mm, 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 I'm I'm still thinking. I think I am I know that this is wrong, so that's why I'm kind of like thinking to
Mhm.
get back. So how do I do permutations? I think to do the permutations is uh, put take an index and then permute the rest of the things. So that that until here is correct. Take an index and then permute the rest of the things. And when I'm permuting the rest of the things, if I am having um, so it's actually permutations is actually um, BFS, and in BFS, what you do is actually have a stack, and you you pop the value and find out everything that's connected to it, which is again the different permutations, and add it back to the stack and return it. So I'll do something like that. Okay. So I'm, I mean I'm going past this 1, 2, 3, but I'm going from the some other example I have. Stack. Okay. Permute. stack. Okay, value is equal to stack.pop of 0. Okay, I will say so for index and range of length of the value. We'll have the remaining equal to the same logic of this value with the index plus and stack append remaining. So what I'm doing here in the permute is actually putting a string in the stack and then popping the string off, and I'm actually going from the value pop, uh, popping the string off and then going to the length of the string and permuting the character the string without this. So I will uh, okay, I will have the value of the index plus the remaining into the stack, and when I do this way, what will happen is will the stack always go through. So not necessarily. So if the stack has ABC, then I will have ABC as popped, and then 1, 0, 1, 2 in the index. Okay, I will have so the um, okay, I will okay, permute value, perm value is equal to this one. Let's see yeah, permutations. Let's just give some list of words. Okay, if perm not in list of words, list of words dot append perm. Okay, and then you do an append of stack append with perm. So what has happened here? Okay, so I have done the list of words with the permute. So permutations, when I go here,
Mm-hmm.
Permute with S, okay, and the all permutations will be actually we are defining a global here, so I would have it in the list of words. Okay, fine.
Mm-hmm.
I'll just do permute yes. Don't need. Okay. Permutation.
I think you have a return value on like,
Sorry.
I think you don't have a return. Will Python doesn't need a return value.
Yeah,
But
it returns none. I will. So I am actually using a global here to kind of like keep track of an already seen permutation and doing some kind of like a breadth first search here and uh, and seeing if that's the thing. Oh, you mean for this? I don't know why this. Okay,
yeah, no.
let's. Shall we try it?
Yes.
Did you? Yeah. Okay.
Uh,
So I'll yeah. Find permutation AB in no. I'll just so let's see if that presents true. Yeah. I think I'm lucky. But yeah, in terms of like my understanding of how I used to do like as I said I had done some kind of like a permutation problem way long before and I was struggling to recollect it. This was the crux of the method I was trying to recollect in terms of like having a stack and popping a value from the stack and then having an index for a particular value and then having a permutations of the remaining value which I'm doing here
mm,
and keeping track of the permutation in a global value, which is like a list of words. And if I had already seen it, I will not permute it. But if I had not seen it, I'll permute it in the form of like a recursive value with a stack, and keeps going. So yeah, this is
let's have a couple of more test cases just to
okay.
be
Yeah,
sure, right?
yeah.
Not
Uh,
just two letter. Let's go with the length of four
okay.
response. Yeah.
It should return true. Let's see if it does. Okay. Uh,
Add some more like how would you kind of go for a corner case? Is what I'm
okay.
trying to get to.
Okay, corner cases. Okay, let's see if the same thing goes for true, and then just reverse it completely. And let me see if I have. Okay, my empty strings was not a good thing. Why is this? It's funny. Empty string. Oh, Uh, list. Okay, I think empty string was like an extreme corner case. Okay. Um,
Okay, yeah. What would be the runtime for this? Uh, time
uh,
complexity for this?
yeah, the time complexity. This is actually so it goes through at the highest level. It goes through a for loop of uh, the length of the string, which let's assume if the length of the string is n, and then it has to go through each of the n, and it has to look at the all the different permute values of it. So my understanding, okay, if all the different permute values is like you take one and then different things, one and different things, one and different things. So it's uh, it's like, sorry, I'm calculating. Okay, so n uh, is it it's it's n. So we are having n, and for each n, I am kind of like permuting all the different n. So it's n factorial because I think each of them will be going one at a time, and then uh, finding out if the value is present in that or not. So that did it was that correct?
Yeah, yeah.
Yeah.
So I just want to know kind of the runtime complexity for this.
Yeah, runtime complexity. So we are going for n in the for loop, and then for each n, I'm still kind of like getting again in the n, traversing the entire tree with the n. So uh, I'm my oh, it's not search. Mm, it's it's n factorial is my it's n into n it's n factorial is my understanding of the runtime complexity.
Okay.
Yeah.
N factorial for the shorter string, right?
Yeah, it's n into n factorial is what I'm kind of deriving, but I'm if n into n factorial is same as n factorial. Yeah.
How many
So,
permutations do you have? Like the list of words, how many um, can it have?
oh, okay. Yeah, it's the list of words have the permutations of n. So it's three, it's six. So it is it's n factorial. So your string of n will have n factorial permutations. So n factorial is going through all the different permutations and getting that thing. It is the runtime complexity of this is um, we have n for the number of characters, and then mm, so number of permutations in the string is n factorial. Okay, n factorial is the length of n. So for this particular implementation, I have like how many times am I executing the stack here? I'm executing the stack while loop. Um, mm, um, mm, mm. It's not in factorial times. It's actually uh, mm, n, and then I will be having n n square. Um, the the complexity here looks to me that it's actually n square. Actually, that the reason I'm explaining that is we are going through n for, let's assume that each of the characters, and then this is another n for each of the characters. and and the that's the worst case complexity that we are looking at, n into n. Hello?
Yeah. So n square is the worst case complexity,
Yes.
you're saying?
Yeah.
Uh,
I, I'm yeah, I'm deriving it, so I'm not entirely sure about this. Yes.
okay. N square can be probably okay. And then the list of words has how many will have how many permutations?
The list of words will have all the permutations of a string. That will have n factorial permutations. Like
N factorial.
n factorial being, so for example, if we have 1, 2, 3, it's supposed to have all the different, for 1, 2, 3, it's supposed to have all the different things. So,
For
uh,
for 4, how many permutations will we have?
for 4, uh, so 3 into 2 into 1, that's actually 12 into 24. So we are supposed to have 24 length. And if, yeah,
So, do you think the permute function should go through all the permutations?
the permute, sorry, I didn't get question. Come again.
So, basically, the permute function, if it has to get all the permutations, it will have to like go through all the permutations, right?
Correct. Yes. Yes. Yeah.
So,
The complexity is not actually n square. It's actually n factorial. That's my, that's the, that's the understanding. Yeah.
so n factorial for the permute function, n
Yeah.
factorial for checking in the word,
Yeah.
and the is also order of n, so it basically becomes n into n factorial.
Yes.
Uh, can you improve the time complexity somehow?
Uh, can we improve the time complexity? Hmm.
I guess we're 45 minutes in, so I'll just take an idea,
Yeah.
like if or kind of where you can improve the time complexity piece.
Yeah. Like in the beginning, I was saying that this approach seems like the straightforward to me, so I was going with this. Okay, this is a costly approach in terms of n factorial, and then finding this one n into n factorial. The time, if we have a completely different approach, wherein if I use some kind of like a bottom-up dynamic programming, where I can use some kind of like indices values in such a way that I will be able to store all the different characters of the string one as some kind of like a map, and then go through the second characters in such a way that if each of the characters in the second string corresponds to the value in the map, then I increment it and then move the window. So I can use a completely different approach, like for example, a sliding window kind of an approach. I'm kind of like recollecting now after solving this in the first approach. Okay, if I have like a sliding window which goes through all the different characters in the string from the length of the first string, and make sure that each of the characters is is present in that string, and increment the sliding window in such a way that when I find each of the characters present in the string, then that kind of an approach will be far more efficient than this n into n factorial approach. Unfortunately, it didn't strike me immediately when I started this problem, but I think that will work. And the time complexity of that will be like we are going through the entire S through only once, and we will be going through each of the characters in the S2 in S1 once. So it will be of the order not like n factorial, but it will be in much lower. Like for example, it will be of the order of length of the second string into the length of the first string. So that can be one approach. Was I able to explain the second approach? A sliding window approach. So what I was trying to say is I didn't write it, but I'm not. So I realized that this is like very costly approach. So what I was trying to say is, if we go to the second string and then take substrings at a time here, okay, a sliding window two at a time, AD, and if both of them present, no. Okay, then go for the DG. If both of them present, no. If, ED, both of them present, no. Use some kind of like a sliding window to solve this problem, a completely different problem. That will be more efficient. Okay. Here in the permute,
yeah, good approach. The thing is, you don't like. Okay, kind of. You'll have to take care of characters instead of or character frequencies, I guess.
Yes,
right?
yes, I will have to take care of character frequencies. Correct. So I will have to take care of character frequencies and make sure that in each sliding window, all the character frequencies in the source string are met. And if that is met, then it's true. If not, it's false. So that would have been the most efficient way of solving this problem. The time complexity of that approach, if I had gone with that, is like the length of the second string multiplied by how many times I'm going for the first string. If I'm making sure that the first string characters are done. A worst case will be like much smaller than that, like length of the second string multiplied by the length of the first string would have been a time complexity of this approach, the second approach I'm saying. Here in the permute function, if I had gone with the first approach itself, is there a way to kind of like improve the complexity here? I'm thinking. So, can I reject any of the characters yearly if the permutation is the stuff? Yeah, I am not able to think of any optimization in the permute function, this approach, where I have to exhaustively get all the permutations before I land up on the solution here. It seems to me that we have to exhaustive permutation of all characters in terms of an optimization. In terms of implementation, is there any other thing? This is a standard breadth first search, so I don't see here. So my answer to can I improve this approach, can I improve this, will be to use a different algorithm which uses a sliding window and matching frequency rather than going with this.
Yeah, I think sliding window approach sounds good actually. What do you think the runtime complexity of the sliding window approach would be?
Okay, the sliding window, so the runtime complexity will be, of course, the length of the second string S2 multiplied by, we have to, so we have, so for, we go one window at a time and then find out the frequencies. We go one window at a time and then find out the frequency of the characters here. So for, let's see, okay. It's okay. so this is worst case. Okay, so I kind of like for each character that's going, it's um so I am having that divided that into different things and this. Uh, hmm. Um, we are going through each character in the second string and each um, we, we are finding out all characters present for the second string, and we are going for like each character in the second string. The worst case, that will be of the order of length of the second string multiplied by the length of the first string. Yeah, it's definitely less than this, but by some slabs value. But this is the oh, sorry, I if you miss the length of the second string and you miss the length of the first string, how much are we going? Are we going from
How
m?
much the approach take usually?
Come again? Sorry.
How much, like, what is usually the sliding approach
Yeah,
runtime complex?
the sliding approach runtime complexity is usually the sum of the two strings actually. Like we go to the second string length with oh, okay. It's actually the sliding approach complexity is usually of the order of like m plus n, which is like the length of the first string with the length of the second string. And
Mhm.
yeah, and even here we are having the same n of the second string with the length of the first string. And are we doing anything further? Nothing. So that might be the answer here too, like of the order of m plus n.
Okay,
Yeah.
awesome. Sounds good. Um, I think for feedback, like it's good to have in your knowledge stack uh, permute and all those kinds of normal functions. Um, you came up with a solution pretty quick, but uh, since it's not a very it's a very costly solution of sorts, right?
Yeah.
So uh, like takes time to get to the actual sliding window approach, which is the better
Optimal.
solution.
Yeah.
Yeah. But otherwise, you got to the sliding window approach without much, without many hints or anything. So that was a good thing. And yeah, I think pretty much it. I think you need to spend some time on figuring out time complexities of stuff.
Thank you. Yes, I realize that too. When I'm practicing, I kind of like think that solution is important and I can derive the runtime complexity if I understand it well. But I just realized that that is not the case. I need to, when practicing also, I need to derive runtime complexity once to solidify my
Yeah.
understanding so that I can do it. Yeah. Yeah. Thank you
Yeah.
for. Yeah.
Okay. Cool. I think otherwise it was pretty good. Yeah.
Thank you. Yeah.
Okay.
Thanks a lot for the interview. Yeah.
Oh yeah, sure, definitely.
Yeah.
Thank you. Bye bye.
Thank you. Bye.